Hello and welcome back. So I have this question still on projectile motions. Say the ball is thrown horizontally from the top of a cliff 20 meters high. If the initial horizontal velocity is 8.0 meters per second, find the following. How long it takes to reach the horizontal plane at the foot of the cliff. B. How far from the foot of the cliff it strikes the ground. And then C. The speed with which it strikes the ground. We have to take G is equals to 9.8 meters per second. So let's start solution. Let's see the values we've been given, and let's see how we can maybe draw a sketch, right? So if you want to pick a sketch, maybe I'll say this is the cliff, and then the ball is here. So when the ball is thrown, it falls down to the horizontal plane, right? Okay, so let's say this is the horizontal plane. Alright, so it reaches here. So this is the horizontal ground. And then this is the ball reaching the ground here, right? So the velocity with which it is thrown, they say is 8 meters per second, right? And then the height of the cliff is 20 meters. It's 20 meters. So we should find how long it takes to reach the horizontal plane. So we are just looking for the time for the whole of this distance, the time, right? So if we recall this formula that says T is equals to square root of 2h over g, we can then substitute our value and get our answer as fast as possible. So this is 2 times the h is 20 all over the g is 9.8, which is going to be giving us, let's multiply, this is 40. So we have square root of 40 divided by 9.8. So we have 40 divided by 9.8. We're going to be having square root of 4.08. And that's going to give us what? Square root of answer 2.02 seconds, right? And time is measured in seconds, so we have 2.2 seconds. All right, so we're going to be having 2.02 seconds. Okay, let's go to the next value. This is A. Option A is answered already. And the second value is how far from the foot of the cliff it strikes the ground. So from the foot of the cliff, this is the foot of the cliff. How far did it strike the ground? So we want to know this distance, right? So how do you get this distance? So if you call the distance d, so distance is speed times time, right? So what is our speed? The speed that we got is what? Speed is 8 times our time, 2.02. So that will give you, distance will give you 16.16 meters, right? Okay, the last but not the least, this is going to be B. The last but not the least said we should look for what? We should calculate the speed with which it strikes the ground. So we can call this C. Now, if you observe the values that we have gotten so far in this calculation, we have, let's bring out the data we have. We have U is 8 meters per second. We have time to be 2.02 seconds. We have acceleration due to gravity is 9.8 meters per second, and the body is falling from a height, that is falling under gravity, not against gravity. So with that, we can use the formula that says v square equals to u square plus 2gh, right? So here, this will be the velocity we are looking for. The initial velocity is 8. The time given is 2. And then the acceleration due to gravity is 9.8. Then the height is 20 meters. So we can substitute value here. V square is equals to 8 square plus 2 times 9.8 times 20, right? So V square is equals to 64 plus 9.8 times 2. So we give you 19.6, then times 20. So we have V square is 64 plus times 20. We have 392. So let's add up this value. 392 plus 64. So it's going to give us 456. 456. So we got 456, right? Now our V will be equals to V square is 456, right? But we are looking for V, so we take square root of both sides. This square will cancel this, so our V is equal to square root of that value. It's going to give you 21.35, and we know that velocity is measured in meter per second, so we have meter per second. All right, that brings us to the end of the question. Bye for now, and see you in the next video.